I want you to imagine something for a second. Put yourself in this scenario. You are walking into a crowded room, like maybe it's a bustling networking event or a really large family gathering or just a packed coffee shop.
Right.
You look around the room, taking in the faces, the conversations, the energy, and then you suddenly realize that you share absolutely no biological traits, no ancestral history, no genetic reflection with a single other person in that entire space.
It's a heavy thought.
It is. Now, what do you think happens next? You might say, well, you would feel lonely or maybe a bit isolated. But what if I told you that for some people, the actual physical lighting in the room, like the literal brightness of the space you are standing in, actually appears to dim?
Yeah, it is a profound and honestly a pretty unsettling image. And it completely challenges almost everything we assume about how human beings process the physical world around us.
Totally.
Because we tend to think of human vision as this purely mechanical, objective process. Light hits the retina, the optic nerve fires, the signal goes to the visual cortex, and boom, the brain registers a room.
Just a camera taking a picture.
Right, exactly. But what we are looking at today suggests that our biological and ancestral connections, or the sudden total absence of them, might actually sit right at the exact center of how our senses calibrate physical reality.
Which brings us to the mission for today's deep dive. We are looking at a stack of incredibly eye-opening sources today.
Oh, absolutely fascinating stuff.
Yeah, and we're specifically focusing on a general public white paper by author Shane Paul Boole. He details something called the neurophenomenology of displaced lineage.
It's a mouthful, but it's crucial.
It really is. Because for a long time, the adoption experience has been looked at as either just a psychosocial adjustment, the emotional hurdles of fitting into a new family, or it just gets lumped into a standard clinical trauma disorder.
Yeah, just standard CPTSD.
Right. But these papers are proposing a massive radical paradigm shift in how we actually understand the adoptee brain.
Yeah.
So, okay, let's unpack this, because the core concept we are dealing with here is something Boole calls adoption qualia.
Yeah, and to really grasp the gravity of what is being proposed here, we first need to understand that word, right? Qualia.
Right, it's a philosophy term.
It is. In philosophy and neuroscience, a qualia is the irreducible subjective architecture of consciousness. It is the fundamental, what it is like to experience something.
Like trying to explain the color red.
Exactly.
Yeah.
You cannot objectively measure the exact subjective feeling of seeing the color red or tasting an apple or, feeling a chill in the air.
Right.
And Boole is applying this concept directly to the adoptee experience. He is positing that the adoptee's nervous system fundamentally, structurally reorganizes itself around the sudden absence of early lineage anchors.
So it's not just a mood?
No, not at all. It is not just a psychological mood or a fleeting emotion. It is an entirely distinct neurological and perceptual reality.
Which is just mind-blowing. I mean, it means we have to stop looking at this purely as a psychological event and start looking at the actual hardware of the brain.
Yes, the physical hardware.
Yeah. But before we get into the literal physical brain changes, I want to explore why traditional science has just missed these perceptual changes for decades.
That's the big question.
Because if people are literally seeing rooms get darker, how does a medical professional miss that? The white paper talks about this deep historical divide and how adoption has been studied.
Yeah, there has been a massive bifurcation in the research for a very long time. On one side, you have the third-person domain.
The clinical side.
Right, your standard clinical scientific perspective. It relies on social work outcomes, standardized attachment theory questionnaires, genetic sequencing, and cortisol swabs.
Hard data.
Exactly, hard objective data.
Yeah.
But on the other side, you have the first-person domain. This is the realm of memoirs, the deeply personal, often ineffable feeling of displacement that adoptees write and speak about.
The pervasive alertness.
Yes, that exhausting alertness, the profound sense of lineage severance.
And historically, those two sides just do not talk to each other, at all.
No, they really don't.
The clinical side often dismisses the first-person accounts as just subjective feelings, stuff that isn't scientifically measurable or reliable.
Well, the first-person side feels completely unseen and invalidated by the sterile clinical data.
Exactly. And the paper pulls a brilliant quote from neuroscientist Richard Cytowic to address this. He says, you can't have a third-person technical explanation for a first-person experience.
Which perfectly encapsulates the crisis in modern adoption research. You can sequence an adoptee's genome and measure their stress hormones in a lab all day long.
Right, swab them every hour.
Yeah, but traditional clinical metrics completely fail to capture things like that dimming room you mentioned at the start. So to fix this blind spot, Boole introduces a methodological stance called sovereign inquiry.
I really want to dig into sovereign inquiry because it feels like the key to unlocking this whole framework.
It absolutely is.
It demands that we treat biological data and the subjective lived experience with equal weight, right? Like, it refuses to let the clinical data just overwrite the phenomenological truth.
Precisely. They have to exist in a productive tension.
Yeah.
Sovereign inquiry acknowledges that if a person tells you the room feels physically darker or overwhelmingly loud, that is a valid biological data point, even if standard optical or auditory tests show their organs are functioning perfectly normally.
I was trying to think of a good way to visualize this for you, the listener, and it kind of reminds me of trying to diagnose a malfunctioning car.
Oh, that's a good analogy.
Right. The third-person clinical data is like the computer diagnostic tool the mechanic plugs into the dashboard under the steering wheel. It spits out error codes about oxygen sensors or fuel pressure.
The raw numbers.
Yeah. But the first-person experience is the mechanic actually driving the car on the highway, feeling the steering wheel shake, and hearing the engine knock at 60 miles an hour.
Right, the actual performance.
You cannot truly fix the car with just the error codes, and you can't fix it just by listening to the knock. You desperately need both to understand the full mechanism.
That is a very functional way to look at it. The diagnostic codes are essentially useless without the context of the performance, and the performance needs the codes to identify the root source.
Exactly.
And if we apply that approach to adoption, treating the lived experience as equally valid to the biological data, we have to find the mechanism. We have to answer the crucial question: what is the actual evidentiary bridge linking the two?
How does emotional displacement physically, anatomically alter sensory perception?
Right. Because it is not enough to just say, well, they feel stressed, so the room feels dark.
Yeah, that sounds like poetry, not science.
Exactly. But there is a literal 4-step neurobiological pathway mapped out in these papers. Step 1 is genetic priming and HPA recalibration.
Okay, break that down for us.
Basically, the early trauma of sudden lineage separation alters specific gene expressions right at the beginning of life. This effectively removes the chemical handbrake on the body's stress response, which is the hypothalamic pituitary adrenal axis.
Without that internal handbrake, the system inevitably reaches step 2, which the paper calls cortisol saturation.
Right, because the negative feedback loop that usually shuts down cortisol production is impaired. The brain is forced to constantly marinate in stress hormones.
Imagine an alarm bell that gets triggered, but the wire to turn it off has just been cut. It just rings and rings.
Which leads to step 3. And this is where the actual perception of reality starts to distort: visual cortex alteration.
Because that prolonged elevated cortisol does not just stay in the emotional centers of the brain.
No, it doesn't. It physically travels all the way to the occipital lobe at the very back of the head, which is the area that processes vision.
Wow.
And once it gets there, it starts disrupting things. Specifically, it disrupts the brain's NMDA receptors and GABAergic interneurons.
Let's break those down because they are critical to the mechanism here.
Sure. Think of NMDA receptors as the tiny neurological switches responsible for processing sensory input and facilitating memory. When prolonged stress hormones jam those switches, the brain's ability to cleanly process what the eyes are seeing gets distorted.
And at the same time, the cortisol is impeding the GABAergic interneurons.
Exactly. GABA acts as the brain's primary inhibitory neurotransmitter. It is essentially the brake pedal that slows down neural activity to keep things clear and focused.
So when you lose that brake pedal,
You get a literal degradation of the signal-to-noise ratio in the visual cortex. What's fascinating here is that this isn't a metaphor, it's a literal degradation.
Meanwhile, as all this noise is happening in the visual cortex, the amygdala, which is the brain's fear center, forms a super tight coupling with the prefrontal cortex.
Yes, it actively starts pushing these high-alert, effective emotional signals directly into the sensory processing streams.
And that anatomical cascade brings us to the climax of this process, step 4, acquired ideesthesia and emotional photism.
Because of this extreme cross-modal blending, emotional distress is not just felt in the chest or the stomach anymore. It is actually experienced as environmental darkening or visual hostility.
Shifts in environmental luminance become inextricably linked to emotional states.
Exactly.
To make this really concrete for you listening, think about synesthesia. You have probably heard of people who have a neurological crosswiring, where they involuntarily taste a shape, or they hear a specific color when someone speaks.
Right, a classic cross-wiring.
Acquired ideesthesia works on a similar principle, but driven by early trauma. It is as if the adoptee's brain, having been deprived of its normal, expected lineage-based predictive coding anchors.
Like the familiar faces, scents, and sounds of its biological family.
Right, it lacks those anchors, so it has to urgently compensate to make sense of the world. So it cross-wires emotional uncertainty directly into the visual feed. The psychological feeling of not belonging literally translates into the visual input of the room getting physically darker.
It is an incredibly sophisticated survival adaptation. The brain is trying to visually map an emotional threat.
But to understand why the brain gets locked into this state, why it doesn't just calm down once the adoptee is placed in a safe, loving home, we have to look deeper, right?
Yes, write down the epigenetic blueprints.
Let's get into those epigenetic risk architectures. Now, the paper is very careful to point out that these are baseline predispositions. They are not biological destinies.
That is an important caveat.
The brain remains neuroplastic, meaning it can change and adapt over time. These systems are constrained, but they're not permanently locked in stone.
The system is plastic, yes, but the starting coordinates are heavily shifted. The primary marker they discuss is FKBP5 hypomethylation.
FKBP5, got it.
FKBP5 is a gene that helps regulate how the body handles cortisol. When this gene is hypomethylated, the biological off switch for stress is fundamentally impeded.
So the threat detection architecture is constitutively primed. It is always running in the background.
Always.
So if the brain is constantly flooded with stress and that off switch is broken, why doesn't it just eventually adapt? I mean, the brain is a learning machine, right?
It is.
If an adoptee grows up in a totally safe environment, why doesn't the brain just learn that the threat is gone and rewire itself to relax?
That is exactly where the second marker comes into play. BDNF hypermethylation.
Hey, what is BDNF?
BDNF stands for brain-derived neurotrophic factor. It is essentially the biological fertilizer for the brain. You absolutely need it to grow new neural pathways and learn new ways of responding to the environment.
Right.
But early lineage separation often leads to the hypermethylation or the suppression of this vital growth factor.
Oh, wow.
So, to answer your question, the brain's physical ability to be flexible and learn that it is safe is severely constrained by its own chemistry.
Here's where it gets really interesting. Because of that suppressed growth factor, you can think of the trauma pathways in the brain as a massive paved 8-lane superhighway.
Yes.
The impulses just fly down that road with zero friction. But the pathways for new flexible learning or the pathways for feeling secure, those are like neglected dirt roads completely overgrown with weeds.
That's a great way to picture it.
Because the brain lacks the BDNF fertilizer to clear those dirt roads, it just keeps fortifying the trauma superhighway instead of effortlessly growing new roads around it. It gets physically stuck in the stress response.
Exactly. And because those dirt roads are neglected and the superhighway is constantly active, the baseline for how they process emotion completely shifts.
Which brings us to another critical piece of the architecture.
Right. SLC6A4, site-specific methylation. This alters the expression of the serotonin transporter.
And serotonin is huge.
Serotonin is a massive player in mood regulation and feelings of well-being. What happens here is a constitutional shift in the emotional ground state.
So this isn't just a bout of standard depression.
No, it is a complete recalibration of the baseline from which the adoptee measures every single emotional experience they will ever have.
And as if altering the emotional baseline wasn't enough, there's also an impact on how they literally navigate space.
Yes, the spatial element.
The paper details KDM6A loss, which physically alters the prefrontal cortical architecture and limbic connectivity, specifically impacting the right hemisphere white matter development.
And that area of the brain is absolutely crucial for spatial sequence reasoning.
Literally how we understand where we are in a physical room.
Yes. And that disruption of spatial sequence reasoning is the perfect pivot point to understand how this early biological trauma actually manifests in the real world.
How so?
Because if you have this unique combination, a prime threat response, an inability to easily rewire those responses, a shifted emotional baseline, and altered spatial reasoning, your day-to-day behavior is going to look very, very different from what clinical psychologists are trained to look for.
Okay, let's talk about what that actually looks like on the ground. Because when we think of standard severe trauma or complex PTSD, what do we usually see?
We see a diminishment of sensory engagement. People numb out. They withdraw.
They get brain fog. They mentally and physically check out of their bodies to escape the overwhelming weight of the trauma.
Exactly. Yeah. But the adoptee experience described in these papers is the exact opposite.
The exact opposite.
It is characterized by something called spatial liminality.
Spatial liminality. So what is that, practically speaking?
It is an acutely heightened, hyper-calculating awareness of physical geometry and environmental exits. It is the immediate subconscious cataloging of a room the second you walk into it.
Because the adoptee lacks the primary social and lineage anchoring that most people just take for granted.
Right. So their nervous system compensates by over-anchoring to the physical space itself.
The body does not feel detached or numb.
No, it feels overwhelmingly, almost painfully, too present in what it perceives as a structurally hostile space.
So imagine you're an adoptee sitting in a high school classroom or a crowded cafeteria. While everyone else is just casually chatting or eating, your nervous system is involuntarily calculating the distance to the door, the exact placement of the tables, the acoustic echo of the voices.
All because you lack that invisible tether of biological mirroring.
But hold on, I have to push back here on the medical side of this. If an adoptee is sitting in a classroom and they are hyper-present, constantly scanning the room, restless, cataloging exits, wouldn't a doctor or teacher just look at that and say, oh, that's severe ADHD?
Yes, they do.
Or maybe just an extreme anxiety disorder. Like, how do we know this is a unique qualia and not just a standard attention deficit that we already have medication for?
That is the exact trap the medical establishment falls into, and it is a crucial point. They assume it is standard ADHD or anxiety because they lack this specific neurophenomenological framework.
They only have a few primary lenses for profound early childhood trauma or behavioral issues.
Exactly. When an adoptee presents with extreme sensory divergence or this spatial hypervigilance, clinicians mistake a highly functional adaptation for a failure to focus or a failure to heal from CPTSD.
They're trying to fit a profoundly unique neurological adaptation into a pre-existing generic diagnostic box.
Right. They see the scanning behavior and prescribe a stimulant to focus the attention, completely missing that the attention is already intensely focused on surviving a spatially threatening environment.
So if a doctor thinks this hypervigilance is just ADHD or standard trauma, what else are they getting wrong?
A lot, actually.
The paper spends a lot of time completely reframing what doctors traditionally call comorbidities, the cluster of other diagnoses that often get tacked onto adoptees.
Yes.
Under this new framework, things like visual issues or learning disabilities are not broken systems at all. They are highly sophisticated, functional adaptations to what Below calls a liminal multiverse.
If we connect this to the bigger picture, the liminal multiverse is a fascinating concept.
Yeah.
It refers to a world where the primary spatial and relational grammar, the fundamental nonverbal cues you learn simply by mirroring your biological family from infancy, was never fully available.
So the nervous system has to build its own grammar from scratch.
Precisely. Take Irlen syndrome, for example.
Right. I was reading about how this affects vision. Irlen syndrome is usually diagnosed as a visual stress disorder, where people are highly sensitive to glare, contrast, and printed text.
They often get prescribed tinted glasses.
Yeah, and it's treated like an isolated eye defect.
But under the adoption qualia framework, Irlen syndrome is recognized as the subjective correlate of the emotional photism we discussed earlier.
Driven by that constant HPA hyperarousal.
Exactly, which
Well,
actually affects the ciliary muscle in the eye and the occipital processing in the brain. It is not an isolated structural defect in the eyeball. It is a downstream trauma adaptation.
The visual stress is a physical manifestation of emotional displacement.
Yes.
What about hearing? Because we see the same pattern with auditory processing disorder, or APD.
We do.
Kids and adults get diagnosed with this when they have trouble understanding speech in noisy environments. They pass a standard hearing test perfectly fine, but they can't filter out background noise in a crowded room.
And it gets treated like a neurological hearing deficit.
But the paper reframes it completely. It is an active filtering strategy. The brain isn't failing to hear. It is purposely shifting into extreme auditory vigilance.
It is constantly scanning the environment for the missing voice of their biological lineage,
Yeah.
or listening for subtle threats.
It is allocating all its resources to threat detection rather than just casual listening.
And if we look at learning profiles, we see the exact same adaptive logic with nonverbal learning disorder, or NVLD.
Right. People with NVLD often excel at rote verbal memory. They have massive vocabularies, but they struggle immensely with navigating novel spatial maps or understanding unspoken social dynamics.
Well, this is a direct consequence of that KDM6A loss and the right hemisphere white matter alterations we talked about in the epigenetic section.
Oh, that makes sense.
The verbal skills become hyper-developed to compensate for the missing spatial and relational grammar. The brain leans heavily on what it can do, words, to survive a world where it cannot instinctively read the space.
I really want you, the listener, to put yourself in those shoes for a second. Imagine moving through your entire life being told by well-meaning doctors, teachers, and specialists that your eyes are broken, your ears are defective, your learning abilities are disordered, and your anxiety is just a chemical imbalance you need to get over.
It would be exhausting.
And then finally, reading a scientifically grounded framework like this white paper that says, no, you aren't broken. Your body has actually been performing a highly advanced, exquisite survival calculation this whole time.
The relief of that validation must be astronomical.
Truly.
It fundamentally changes the narrative. The difference between being told you are a broken machine with faulty parts and being told you are a highly successful survivor of a fundamentally altered reality.
But Bull is clear that to ensure this doesn't just remain a theoretical thought experiment in academic circles, we have to move it into practice.
Yes, the papers outline a very clear, progressive path forward for testing and validation.
Right. The rubber has to meet the road clinically. They propose a progressively accessible, tiered diagnostic protocol.
Tier 1 is all about clinical accessibility.
Things that can be done in a standard therapist's office.
Exactly. It involves using a structured sensory mapping inventory. So instead of just asking an adoptee a vague question like, are you depressed? Therapists would systematically evaluate the consistency of spatial liminality and emotional photism.
Asking things like, does the room change brightness when you are stressed? Do you involuntarily catalog the exits?
And they pair that subjective mapping with accessible, low-cost physical tests, like saliva cortisol tests taken throughout the day, to actually check the rhythm of the HPA axis.
That provides an immediate practical baseline.
Then, for rigorous research and validation, tiers 2 and 3 escalate to academic cohorts. This is where we deploy the heavy machinery.
Like fMRI neural architecture mapping to actually measure the prefrontal limbic coupling in real time.
And multi-omic epigenetic methylation panels.
Let's break that down for a second. So instead of just looking at one single gene in isolation, these multi-omic epigenetic panels look at the entire landscape.
Right.
They look at how these specific markers, the off switches like FKBP5 and the plasticity constraints like BDNF we talked about, are actually expressing themselves and interacting across the whole body in real time.
Exactly. It maps the entire network of epigenetic changes. But perhaps the most crucial element of their research proposal is the design of the advanced control groups.
This part is huge.
They argue that future research cannot just compare adoptees to normal, non-traumatized control subjects, because that muddies the data.
They insist that researchers must compare adoptees specifically to lineage-intact individuals who have experienced matched early adverse stress. So what does this all mean? Why is that detail so important?
It means they're isolating the exact specific variable of lineage displacement from general childhood trauma.
If a child who suffered severe trauma but stayed with their biological family doesn't show these specific sensory changes, but an adoptee does, then you have proven that the loss of lineage is the active ingredient causing the qualitative shift.
This raises an important question regarding epistemic humility in the scientific community. For so long, we have assumed that trauma is trauma is trauma.
A stress response is a stress response.
But by demanding control groups that separate lineage severance from general adversity, this framework forces the scientific community to rigorously test and likely acknowledge what adoptees have been saying all along. This experience is fundamentally different.
We must map the deep biological interiors of this qualia.
But we have to do it while remaining tightly tethered to the profound, irreducible reality of the people who actually live there. We cannot ever let the biological map overwrite the human territory.
And that is really the ultimate message of this white paper, especially for the adoptee community listening to this deep dive right now. This framework offers a brand new vocabulary.
It proves that the biological is the experiential.
The way you perceive the light in a room, the way your eyes track the geometry of a hallway, the way your brain actively filters sound, is a scientifically grounded, phenomenologically coherent reality.
You're not a collection of broken parts.
No. Your nervous system is exquisitely, brilliantly calibrated to a completely different set of coordinates.
It bridges the gap. It validates the first-person experience with third-person science, creating a unified understanding of what it actually means to survive lineage severance.
It really does. And it leaves me with a thought that I have not been able to shake since diving into these sources. If a human being's nervous system can literally alter how physical light, space, and sound are perceived purely based on the sudden absence of their ancestral lineage, what does that imply about the rest of us? It suggests that our baseline perception of reality, our very consciousness, might not be a solo endeavor at all. It might be something continuously held together, calibrated, and illuminated by the invisible biological tether we have to our ancestry. So, the next time you walk into a crowded room and the lights seem bright, stable, and welcoming, well, you might just have your unseen lineage to thank for the view.